One-step equations. There are some hints to remember when solving one-step equations. To solve equations, you must work backwards through the order of operations to find the value of the variable. Remember to use inverse operations in order to isolate the variable on one side of the equation. And whatever you do to one side of the equation, you must do to the other side to keep the balance. So now let's look at a couple examples of some one-step equations. So here we have y plus 9 equals 16. So the inverse of adding 9 is subtracting 9. So here they eliminate on the left side, and 16 minus 9 is 7. So we have y equals 7. In the one step with our inverse operation, we've now arrived and solved our equation. In this example, 6m equals 72. It's 6 times m. So the inverse of multiplying by 6 is dividing by 6. So that on each side, if we divide by 6, will leave us with m equals 12. Again, in one step, dividing by 6, we've arrived and solved our equation. Here we have two more equations. X minus 8 equals negative 2. Here our operation is subtracting 8. So the inverse of subtracting 8 would be to add 8. If we add 8 to both sides, it will eliminate from the left, leaving us with just x, and negative 2 plus 8 is 6. So x equals 6 is our solution. Here we have 2 equals x minus 6. So currently they are subtracting 6. The opposite of subtracting 6, or the inverse, would be to add 6 to both sides. That would then cancel the negative 6 and 6, leaving us with x, and 2 plus 6 is 8, giving us an answer of 8 equals x, and you can even switch it around to be more correct. X equals 8. Here are two more examples. We have x plus 2 equals negative 14. Currently they are adding 2, so the inverse would be to subtract 2. Now if we subtract 2 from both sides, that will eliminate from the left to leave us with x. And negative 14 minus 2 will give us negative 16 for our solution of x equals negative 16. Another example, 7 equals x plus 3. Currently, they're adding 3. The inverse of adding 3 would be to subtract 3. If we subtract 3 from both sides, it would eliminate from the right. And 7 minus 3 is 4, leaving us with 4 equals x. And more correctly, if we switch around the equal sides, x equals 4. Two more examples. We have x plus 5 equals 3. Currently, it's adding 5, so the inverse would be to subtract 5 from both sides, eliminating the 5 from the left. And 3 minus 5 gives us our answer of x equals negative 2. This example, 15 equals x plus 17. We're adding 17. The inverse of adding 17 would be to subtract 17 from both sides. That would eliminate 17 from the right. And 15 minus 17 is negative 2. And if we switch around our variable to the left, x equals negative 2. Here we have 3 times x equals 15, negative 4 times x equals negative 12, and negative 25 equals 5 times x. The inverse of multiplication is division, so in each example we're going to divide by the number instead of multiply. Here we have 3x equals 15, so instead of multiply by 3, we'll divide by 3 each side, which will eliminate the 3, leaving us with just x equals 5. This example will divide by negative 4 on each side, which eliminates from the left, leaving us with just x equals 3. And here we'll divide both sides by 5, leaving us with just 5 equals x, or x equals 5. Finally, 2 more examples with division. It's currently dividing x by 2 and dividing x by -6, so the inverse would be multiplication. If we have x divided by 2 equals 10, we're going to multiply both sides by 2, eliminating the 2, leaving us with x equals 20. Here we'll multiply both sides by -6, which will eliminate the -6, leaving us with x equals -216. So when solving one-step equations, you have to identify the operation that is currently happening to the variable, determine, and do the inverse.